So the next challenge statement is layout information gathering for as-built services in the ceiling space. For this challenge statement, we will be having using Chan. Nice to see you. From Penta-Ocean Construction. Over to you, Eugene.
Thanks, Zipeng. Hi, everyone. I'm Eugene Chan I'm a BIM specialist from Penta-Ocean Construction. So today our challenge statement is actually how might we survey the layout of as-built services in the ceiling spaces while minimizing the need to open up the individual ceiling panels. Next slide, please. So basically our challenge statement arose from this addition and alteration works that us main contractors need to perform sometimes. So basically for the addition and alteration projects, we need to check the actual layout and conditions of the as-built services. So this includes verifying information with the as-built drawings for things like air-conditioned ducts, water pipes, and electrical trays. So yes, we need to verify it because a lot of these buildings tend to be quite a few years old, and sometimes unverified sort of addition and to the ceiling services has been added that we are not aware of, so we need to find out. And currently what we're doing is that we get workers to use height access equipment, things like ladders, boom lifts, to access the ceiling and then open up the panels. So over then, we'll get a supervisor to either visually inspect the ceiling, record the details, and take pictures for reference. So sometimes there's a need for these workers to also climb into the ceiling as well for closer inspection. And this might pose a safety issue. Yeah, so one of the technologies that we are trying to adopt is actually LiDAR. So we've been trying to use LiDAR to improve step 3, to increase the usability and the accuracy of the information recorded. So a LiDAR is like a handheld thing you can see in the picture on the right. Next slide, please. Yeah, so these are just some key characteristics that we're looking out for. So the solution would be able to portray the position and size of the as-built services, capture things like material type and colors, because that can differentiate between the different services, and as well as identify some smaller key details like valves. Yeah, so also the solution has to consider how this inspection will be done at height. As you know, ceilings are usually more than 2.4 meters high, and there's quite a large area to cover most of the time with minimal manpower. And the information captured should also be able to be converted to a BIM knowledge base. Next slide, please. Yeah, so we have consolidated some key considerations for our innovators. Basically, firstly, the manpower numbers of the workers have to be reduced, and the safety of the workers have to be increased as well. And as well as decrease the time needed to survey our as-built services or increase the accuracy, details, and usability of the information. So what I mean is that currently we take pictures, we make some sketches and stuff like that, we compare it to the drawings. So how we increase the details is things like 3D models or LiDAR, for example, where we can actually capture the information and survey the built services into a 3D BIM model. Thirdly, also to minimize the disruption to the existing occupants of the room. So if we were to open all the ceiling panels, the occupants would be disrupted and we'll have to put them back. So this is quite disruptive to the occupants. And as well as the information should be, as I mentioned before, it should be converted to BIM platforms. Also, the last point is actually quite important, as these ceiling spaces tend to be very tight, uneven, and dusty most of the time. So there's also not a lot of light. So this solution must be able to survey and record under low light conditions. And as well as these ceiling panels are usually aging in nature, and there's a weight limit of probably 1 to 2 kg. Next slide. Yeah, so just to wrap up, we hope this solution can gather the details of layout, the details and the layout of the as-built services in the ceiling spaces, while minimizing the need to open up the entire ceiling. So probably we're looking at maybe 1 or 2 panels, or maybe a few panels every 10 meters, for example, not opening up the entire ceiling. And as well as reduce the time needed to perform this entire operation that we are currently using the existing methods. Yeah.
Thanks,
I
Eugene.
think that's all.
Yep. So once again, you can submit your question using the Q&A button. Eugene, are you able to share a bit more regarding the experiment you did with LiDAR? One innovator, not too sure whether you have these details, asked regarding the brand of LiDAR sensor that you had tried.
I think the LiDAR sensor that I'm aware of, the GeoSlam is probably the smallest one because it can be handheld. Like that's the GeoSlam in the picture, so it's about the size of a football. Yeah, but that is also a challenge currently because it's usually ceiling spaces. There's not a lot of space also. So if we were to, for example, put this sensor in, there's also not a lot of space. And as I'm aware, this is the smallest one so far. That's like for professional industrial standards. Yeah.
Okay. Just a heads up that your connection is little unstable, but we're still hearing you fine. Okay. So for all this A&A works, right? Do you have existing as-built buildings? Because mainly you are looking to update the as-built drawings, right?
Yes. Okay, so we have some existing projects. As in your question is whether we are currently employing this LiDAR thing in any of our projects, is it?
Yeah, you could share more, but we're just thinking like how much does all this information regarding the services, right, need to be collected from scratch? Already you have some drawings that could be a starting point.
Okay, so usually for A&A projects, there's this as built drawing. So for example, like if the client wants to overhaul the entire aircon system, for example, then we will need to check all the existing ducts and as well as the connection to these ducts. And whether this like our new sort of layout would clash with other existing things. So definitely is basically we need to record all the information, almost all the information about the services in the ceiling.
Okay, the next question is from James. Is there a LOD required for BEAMP? And what accuracy are you considering?
Okay, so I think probably we're looking at LOD of maybe somewhere around 2 to 300. Because the reason for this is that we will want to initiate like clash detection. So definitely it needs to be somewhat fairly accurate in some sense, because smaller things like cable trays and even some pipes, they can cause problems if the clash detection is not found out early.
The next question is from Toon. If the key features of the solution must be prioritized, what will be the order? Sometimes it's hard to fulfill all key features, especially for operation in tight space with weight constraints.
Okay, I think to answer Toon's question, probably the key features would be we will want to find out what is in the ceiling at a quicker pace. For example, like now currently we need to open up all the ceiling boards and then we need to check one by one, check everything. So probably to sort of answer his question, maybe we could open just one ceiling board and then put put a sensor, put a scanner inside, and then somehow it can map like maybe 10 or 20 meters into this in a circular manner or something. So that would definitely minimize the amount of time needed to open up all the boards in concept. So probably the key features would definitely be time constraints and as well as the accuracy of the information.
Okay. Our final question from James is the data required to reconcile to survey coordinates.
Is data required to reconcile to? Not exactly sure what he means. probably the data, like geo-reference data.
Yep. Yeah. So I think it's about mapping out on top of scanning what is the service, whether you need exact coordinates or not.
Yeah, I think definitely exact coordinates would be preferable, because we usually have like existing ANA building, there's these references already. So I don't think it should be that difficult to geo-reference whatever information that we collect from this platform or solution. Yeah. So probably, yes, we would want it to be geo-reference.
Okay. Yeah. Thank you. Yeah. Thank you for answering those questions. If you all have any further questions, feel free to drop us an email. And thank you. Now we will be moving to the next challenge statement.